So yesterday you guys did all the vocab already. Can you help me read, Hannah? Can you help me read the degree of a polynomial? What does it say in your paper?
Three. I've got A equivalent power box plus B equivalent power box.
The degree of a polynomial? Someone else read the degree of a polynomial? What does it say? The sum of an exponent? No, not degree of polynomial. Carly?
The largest exponent of a variable?
Yeah, the largest exponent. Remember, this is a degree of a polynomial, not a monomial. A monomial is the sum of exponents, but the degree of a polynomial is the biggest one, okay? Because we're going to use it soon. Number one, y equals negative 4 plus 3x squared minus 6x to the third part A. Writes the polynomial function in standard form. What that means is it wants you to put it in order from highest power to lowest. All right. Which term has highest power? Negative 6x to the third. Next. What's the next one? So positive 3x squared. Next. That's right. Okay, so now it's in order. Name it based on the degree. What's the degree here? Trinomial is later, C. What's the degree? What's the highest degree? 3. So this is called what kind of function? Cubic function. And we already graphed cubic function in HK form, right, y'all? Yeah. Now C is where Anthony came in. Name it based on the number of terms. This is now a trinomial because how many terms does it have? 3. Trinomial function. So that's how we name it, based on different things. Okay. The first 3 things, we're going to graph it by hand, and then the next 3, we're going to do it by calculator. You guys all know how to graph these by hand. Are you ready? First one, what's the name of the first one? Constant. Anybody know what the word constant means? Does it change or does it not change? It doesn't. It doesn't have to. Remember, a function does not have to be continuous. It just, for this one, it says constant function does not change ever. Wherever x is, y is always what? At 2. All right, bust out your ruler. Graph it. When y is 2. Y equals to 2. Whatever x is, doesn't matter. Y is always 2. Okay. Then we're going to go down quite a bit to answer all of the parts. Okay, we have a bunch of parts. Okay. Part number 1, degree. What is the degree of a constant function? What's the degree? Remember, what's the degree again? What's another word I can substitute for degree? Power. What's another word I can substitute for power or degree? Exponent. Okay? So the degree is the highest exponent. Well, what's the highest exponent here? I hear 2, not 2. I hear 1, not 1. 0. Okay, and here's why. This is technically f of x. If I really wanted to, I can write 2 times x to the 0 power. And let's look at it. What's anything raised to the 0? Anything raised to the 0 is 1. 1 times 2 is 2. So that's why this degree, y'all, is 0. Okay. For this particular equation, y equals 2, what's the x-intercept? There is none. 0 x-intercept. None. How about number turning points? None. Did it change direction? Nope. Now, this is the new thing right here. This is Mrs. Lloyd typed it like this. Can you guys see x and then arrow and then negative infinity? Okay. I'm going to spell it out for us. Verbally, this is really said. As x approaches, okay, verbally, here it is. As x approaches, that arrow means approaches. What is it approaching? Negative infinity. okay, as x approaches negative infinity. Now let's look at our graph to make sure we can answer this correctly. Where's negative infinity at? To the right or to the left? Left. As x approaches negative infinity, what's y? 2. Ah, y is 2. This is a constant function. It doesn't change. Right? As x is approaching negative infinity, y is 2. So we write y is 2. I'm spelling it out verbally is because it's the very first time seeing this stuff. Now, if you go on to pre-calc and eventually calculus, here's your limit notation. That means this is for higher math. In higher math, we write it a lot quicker. It says the limit as x approaches negative infinity, okay, of your function, which is called f of x, whatever f of x is, equals. What does it equal? As x approaches infinity, what is y? 2. So this equals to 2. Okay. So this right here is verbally spelling it out. This is saying the same thing except mathematically. This is a lot quicker. You guys see that? Now how about the bottom? As x approaches what? Infinity. What's y? 2. You're right. Okay. So that's as x approaches infinity, y is 2 verbally. As x approaches positive infinity, y is 2. Okay. And then in higher math, we use limit notation. Limit x approaches what? Infinity of this function, whatever that function is, whatever function you're working with, equals 2. Perfect. Okay. So these are some new terms or notations. All right, let's go and graph the second one. What does the second one look like? What is that? How would we graph that one? Tell me. Start at -3 on the y-axis. Perfect. What's your slope? 3 over 2. Go up 3 over 2. Do it all the way until you fill up the whole grid, just so you have a nice straight line. Okay, so that's my line. Then we're gonna go downward and answer all of the parts. Okay. What is the degree?
1.
What's the highest power? 1, because x technically to the 1. How many intercepts do we have here?
1.
How many x-intercept? I should be more clear. 1. How many turning points did it have? Does it have? 0. It doesn't turn. It just go one way, right? Now, as x approaches negative infinity, bless you. What's y?
-3.
Right. As x, this is x, approaches negative infinity, right? From this way to the left. What's y approaching? Negative infinity. Okay, but here's a word that is not the same as the first one. Can you see the first one? We wrote y is 2. Okay. For this one, because infinity is not an exact pinpoint location, we say y approaches. Y approaches what? Negative infinity. Okay, that's the difference between if you have an answer and versus you have an infinity. So on this line, we write negative infinity. Bless you. Now, limit notation, we do the same thing. We say limit as x approaches negative infinity of our line, which is, we call it y equals f of x, what's the answer? Negative infinity. You're right. Can you see that all of them is asking the same thing? This right here is algebra 2 sort of notation. This is verbally saying it out, and then this is higher math notation with the limits. Okay? Now let's answer the next one. As x approaches positive infinity. All right, so let me walk positive infinities which way? Right or left? Oh, I'm going right. What's y going? To positive infinity. You're right. So this is, we're going to say infinity and spell it out. As x approaches positive infinity, y approaches what? Yep. Okay, so limit notation, very similar. So limit as x approaches positive infinity of our function, which is a line, it equals to infinity. So those are just different notations, okay? Now, we have one last one to graph by hand, and then we're going to bust out our calculator. What kind of function is the next one? What is it?
Quadratic.
Quadratic, you're right. Okay, so here it goes. Okay, how do we graph a quadratic? You guys have already done this on an exam. What do we find? What is that called? The vertex. Let's find the vertex. If it's in HK form, do I have to find the vertex? Because it's already there. But it's not in HK form, okay? Vertex x coordinate is negative b divided by 2 times? 2 times a. Okay, what's your b value here? 2, so negative 2. What's your a value? 1. So this is, what's your x coordinate? Negative what? Negative 1. How do I get the y coordinate of our vertex? Plug it in. So f of negative 1 is quantity negative 1 square plus 2 times negative 1 minus 3. All right. Give me the output when you're ready. Is it 0? Negative 4? Okay. So right away, you have a vertex at negative 1, negative 4. Is that okay with all of us? Now remember, we were graphing by transformation. So I was asking you what was A, what was H, and what was K, okay? Because if I know these, then I can transform. Can someone tell me what A is?
1.
Great. So do I have any transformation for A? No, there's no vertical stretch, there's no vertical compression, there's no transformation. What's your H? Good. What's your K? Good. If H is negative 1, what kind of transformation is that? Left. You're right. Left how much? 1 unit. If K is negative 4, what kind of transformation is that? Down how much? 4 units. Then I am going to ask you for a quick parent function. Okay? What are negative 2, negative 1, 0, 1, and 2? Give me the 5 outputs quickly. 4, 1, 0, 1. Oops. 4, 1, 0, 1, and 4. Okay, I have a transform. What do I do with the negative 1? That's right. X minus 1. What do I do with the K? Okay. All right, let's transform all the X's. Where are they now? These are my parents. I need to put them over here. What are they now? Negative 3, negative 2. What is it?
Negative 1, 0, 1.
Okay. Then let's transform all the Y's. These are the Y's. I need to put them over here. What are they now? 0. Negative 3. Negative 4. negative 3, and back at 0. All right, let's plot. Here we go. Negative 3 is stationed at 0. Negative 2 is now negative 3. Negative 1 is negative 4. 0 is 3. I'm sorry, 0 is negative 3. And here it is. Should I make a V? No, that would be wrong. So please do not make a V. I would cry. Okay. If you miss your dots, just make them really fat. There you go. All right, I got my U. I'm going to wait for you guys to copy that down so I'm not going too fast. Ready? Okay. Let's fill out the bottom. What is the degree of this function? 2. You're right. Okay. How many number of intercepts do you see? 2. And here, let me connect the dots for you. If your function or equation has a degree of 2, then at most, you should have 2 intercepts. What do I mean by at most? There's no more. So 2 will be the max if your degree is 2. How many turning points do you see? 1. And let me connect that dot for you. If your degree is 2, the number of turning points is at most 1 less. So if your degree is 2, the most turning points you're going to have is 1. If your degree is 1, you would have at most. What if your degree is 3? What's the max number of turning points? 2. 2. That's right. So that's how we know. Okay. So we're going to spell this out. As x approaches negative infinity. Remember, negative infinity. I'm going to go to the left. What's happening to x approaches negative infinity? Y is what? Y is approaching positive infinity because y is going up. So this is positive infinity. Okay, so let's spell it out. As x approaches negative infinity, y approaches what? Infinity. Okay, I'll spell positive, so when you're saying it, it's limit notation. Okay, limit x approaches negative infinity of our function, in this case is the quadratic, equals, what should I write equal to? Equals what? Infinity. Okay, as x approaching positive infinity, what's y approaching? Also infinity. Okay, so these are the end behavior. What do I mean by end behavior? What do you mean by end behavior? Right, the behavior of the graph. Okay, you're right, and that's what it means. The behavior of the graph, as I go really, really big, or I go really, really small. Okay, what is the graph going to go? What is it going to look like? What is it heading towards? Okay, so why don't you verbally spell that out for me, and then I'll write in the limit notation. Limit as x approaches positive infinity of our f of x, it should equal to positive infinity again, and you can verbally spell that out. And then this is where we're going to bust out our calculator. Once you're done verbally spelling that out, can you turn on your calculator? Done. Perfect. Good job. I want you to clear it out because some people might have messed it up for you. Can you hit second plus sign? Second plus sign? Reset. You're right. Reset, just like we do all the past days. Okay? All RAM. Okay? So second plus sign, reset, all RAM. The reason is that so that way people who borrow the calculator for you didn't mess it up for you. Even if you have your own calculator, it's just a good idea for you to reset your calculator. If you have one between the two of you, then just kind of switch back and forth. Anybody does not know how to reset? Second plus sign. Everyone hit second plus sign. Okay. Reset. All RAM. So is your calculator saying RAM clear? Okay. Can you find the button that says y equals for me? Where is that? Someone shout it out.
Top left.
Top left. Find y equals. Can you scoot in so you can see the twins? Can you see y equals? Everyone on there? Okay. What happened?
I don't know.
Remember, y equals. There you go. Anyone who don't know where? I want you to go there. Y equals. Can you see like a bunch of y equals? Okay. I want you to enter this equation on our notes packet here and project it. You're going to be so amazed. You're like, why didn't you tell me this earlier? Okay. We are about to graph the cubic function. So can you enter in this piece? Whoops. And I'm going to show you what the x variable is. Okay. Can you find the button under mode? Can you locate mode? Under it. There's an X, there's a theta, there's a T, there's an N. Can you see it?
Yeah.
Hit that button, because that will give you X. Did it come up X?
Yeah.
Then can you see a square power has its own button, but anything beyond that it doesn't? Can you see there's a caret? Can you find a caret? Okay, can you see it? Find a hat looking thing. Under what word?
Clear.
Under clear. Okay, under the word clear there's a hat. Can you press that? That will allow you to enter in the degree, like 3, 4, 5, 6. What degree are we entering here? 3. Good. Enter in 3. Okay. Now go to the right to get back to the non-degree and enter in the rest. 5x plus 2. 5x plus 2. Great. Hit graph. No. Yeah. So x squared minus 5 plus 2.
Whoa.
X, so under mode, x t theta.
What the shit?
Okay, I need you guys to all have a curve. Everybody has a cubic looking thing? Okay, I need you to reset your calculator. Second plus sign, reset. You too. Second plus sign, reset. Okay? No, you need an x variable. You don't have an x. X to the third. Go back. Clear that.
Reset the entire. Get out of here.
Find x. Where's x? There you go. Now, right angle minus 5x. There you go, much better. Okay, do it again, because you make clear cut. Okay, y equals. Where are you? Go back to y equals. Hit graph. Okay, utility calculator. You guys think utility calculator. Second plus sign reset. Yeah, do it again. Reset all RAM. All RAM. Yeah, right now it doesn't. So okay, now go and type in x to the third. So x there. Okay, now and then caret. There. Anyone does not have a cubic curve on the calculator? Just all working out. Perfect.
Is it -5 or -5?
Okay, so hit graph. Minus 5x and then plus 2. Hit graph once that's done entering. Not any of the buttons, just hit graph. Where's your graph button? Top right. Anyone else has it? It's just kind of getting it to your calculator. From table to calculator. Okay, this is where another one goes. Whoa, what? I want you to hit second graph. What do you see? Everything you ever need. Can you go up and down for me? Go up and down for me. Or up as well. Are they negative value for you to use? What? You mean like you don't have to do by hand? Okay, here's where I'm going to ask you to give me all of those values. We'll start at -3. Negative 3, negative 2, negative 1, 0, 1, 2, and 3. Okay? So, James, at negative 3, what did your calculator say?
Negative 10.
Negative 10. Lena, at negative 2, the calculator says what? Hope, negative 1, calculator says what?
6.
Gemma, 0, calculator says what? 2. Amanda, 0, at 1, calculator says what?
-3.
Someone confirm that? Because Amanda's questioning.
A lot of them are wrong. I don't know what happened.
At 1, what is it? What did the calculator say? At 1. Negative 2. Amanda, do you have negative 2 in the calculator?
No, I don't.
No.
It like went all weird.
It went all weird.
All the values.
Let me see your equation. Okay, you didn't use minus. You used a negative. Minus. And then, guys, the graphing calculator, the minus button is different from negative. Okay, so now take the table again. Okay. Got it. All right. So we are now at, okay, at 2, Kennedy, with 2, x2, the calculator says what?
0.
And then Hannah, when x is 3, the calculator says what?
3.
Uh-huh.
3 is 20.
Beautiful. Is that enough to plot? Oh, yeah, plenty. Let's do it. Negative 3, I have to go all the way to negative 10. Negative 2 is positive 4. Negative 1 is positive 6. 0 is positive 2. 1 is negative 2. 2 is back at 0. And 3 is 14. You can extend that a little bit. 11, 12, 13, 14. Don't be shy of extending your graph. Okay. Now, if you look at your calculator, would you agree that it looks like this? Isn't the calculator wonderful? Yeah, it speeds up the process, isn't it?
Yeah, why didn't we use this?
I know. Why didn't we ever use that? Okay. Now that we have it down, I'm going to stop right there, and then I need to hand you